Hello everyone. In this video, we will learn about the basic concepts of CPU scheduling. In a single processor system, there is only one process that can run at a time. Other processes must wait until the CPU is free and can be rescheduled. The main objective of multiprogramming is to have some process running at all times so that we can maximize the CPU utilization. A process is executed until it must wait, typically for the completion of some I/O request. In a simple computer system, the CPU then just sits idle. This waiting time is wasted so that no useful work is done. With multiprogramming, this time can be used productively. Several processes are kept in memory at one time. When one process has to wait, the OS takes the CPU away from that process and gives the CPU to another process. This pattern continues. Every time one process has to wait, another process can take over the use of the CPU. Scheduling of this kind is a fundamental OS function. Maximum CPU utilization is obtained with multiprogramming. The process execution consists of a cycle of CPU execution and I/O wait. CPU burst is followed by I/O burst, and CPU burst distribution is of the main concern. As shown in this figure, we could see the process execution is happening and it's consisting of a cycle of CPU execution and I/O wait. We can see the CPU burst is followed by the I/O burst. CPU scheduler. Short-term scheduler selects the process from the processes available in the ready queue and allocates a CPU to one of them. CPU scheduling decisions may take place when a process switches from the running to the waiting state, switches from the running to the ready state, switches from the waiting to the ready state, terminates. Here, the scheduling under 1 and 4 is non-preemptive or cooperative. Otherwise, it is a preemptive scheduling. Dispatcher. Dispatcher module gives control of the CPU to the process selected by the short-term scheduler. This involves switching the context, switching to user mode, jumping to the proper location in the user program to restart that program. Dispatch latency. It's the time it takes for the dispatcher to stop one process and start another running. Scheduling criteria. CPU utilization. To keep the CPU as busy as possible. Throughput. It is defined as the number of processes that complete their execution per unit time. Turnaround time. It is defined as the interval from the time of submission of a process to the time of completion. Waiting time. It is defined as the amount of time a process has been waiting in the ready queue. Response time. It is defined as the amount of time it takes from when a request was submitted until the first response is produced. In this video, we have discussed about the basic concepts of scheduling. Thank you.